Okay, here's an extended hint. Okay, so people are still having problems. Now, here is some student data. Here are the incident angles, 15, 30, 45, 60, 75. And here are your transmitted angles. If this is in glass, this was a little cartoon experiment, right? Now, what we should do is, I kind of left this a little bit open-ended to see if you all would figure it out, but to take the sine of the angles, we need to convert these angles to radians. You can do it in one step. So like it would have been really spelled out for you if I'd had another column for the instant angle in radians. But I didn't do that because I want to see if you all could figure it out. But okay, so let's do that. So we're going to convert this transmitted angle here, these are degrees, into radians. So what do? We type that we have to have the angle, that's 10 degrees, times pi over 180. Now you have the angle in terms of a number. That's the way computers think. Computers think in terms of numbers, right? So, and then we need to get all of them. So I'm going to pull this down. Now we have all radians. That's 10 degrees. 0.175 radians is 10 degrees. 0.332 radians is 19 degrees, and so on and so forth. Now, let me show you how to do it in one step. Okay, so we need to take the sine of these angles. Now, this is not in radians, but watch how you can do it in one step. You can go down here and you can say equals sine of the instant angle times pi over 180. See that? Boom. Now, there you go. Now I'm going to pull that down. And obviously that's the last value. And that one doesn't count. There we go. So that's the last value there. That's 75. That's the sine of 75 degrees right there. Well, we had to convert it to radians. See up here? We had to take the angle A6 and convert it to radians and then take the sine of it. Now in this column, you've already got the transmitted angles in radians here. So here we can just say equals sine of D6, right? Boom. And then you pull that down and get all of them. Okay, now what's your index of refraction based on those measurements? Well, you just divide sine theta incident over sine theta transmitted. And you can see that it's close to 1.5 as expected. Pull them down. See how they're all about 1.5 as they should be? Now what's the speed? Equals, okay, you take the speed of light in air, which is about 3 times 10 to the 8th meters a second. 3e8, we're using scientific notation, over the index of refraction. Light slows down in a material. Well, I'm having some issues here. There we go. Whoops. What did I do wrong here? Equals 3e8 divided by this number. There we go. C15. There we go. Now, that's the speed. See how the speed of light, see how it got reduced? It got reduced by this number. Now, what's the wavelength? Well, the wavelength in air is 650 nanometers, as stated over here. That's that red laser beam. So you say equals 650 and divide by the index of refraction. Boom, we got it. See how it gets, that would be blue light. Now, the light doesn't look blue, does it? If you're in a swimming pool, somebody jumps in with red trunks, they still look like red swimming trunks. So that tells you that your eye really doesn't see wavelength, it sees frequencies. It's interesting, isn't it? Because the frequency doesn't change. If you study the theory, you'll see the frequency of light doesn't change, the wavelength changes. Okay, now let's do the average here. I'm going to do these values just so you can see how to do it. So you get your tabular average, you say equals average, and you just do this. And grab that population. See that? That's all of it. See it up here? I need to put equals average in here, don't I? There we go. So there's our population. Got it. Now, something happened here. Equals average. Do it again. Average of the population. There we go. Now watch this. This is really slick. I can just do this. Pull it over, and it gets all averages each column. Is that not slick? Now we need this in scientific notation, so I'd right-click, format the cell, put it in scientific notation, with 2 decimal places, good enough. There you go. See that? Now, this only needs, this really doesn't need all these decimal places, so we'll fix that up in a minute. Okay, what's the standard deviation? Equals STDEV. Grab that population. See that? Now, let's go over here and grab all of them. We'll get all the standard deviation. See that? Look at that. Isn't that cool? It does it for you. So that's the standard deviation of this group, and that's the standard deviation of this group. So let's fix these cells right. So this needs to be scientific notation. Format the cells. Scientific notation. I thought I formatted these. Maybe somebody changed it here. 2 decimal places is good, indeed. Now, here we only need no decimal places. Just do it, format cells, make it a number, just to make life easy for you. No decimal places. There you go. Now, so what's your table value? 1.51 plus or minus 0.02. And you can underline that. Slick, eh? And I can't underline it because I can't grab, it's hidden from me up here somewhere. Anyway, I can just do this, plus minus. Okay, so let me make this, well, anyway, that's good enough. Okay, equals, now watch this, 1.99 plus or minus 0.02. Do you all see that? Because this is e to the 8, this is e to the 6, so that 2 would be in this, would be equal at this 9 spot here. So E8, there you go. There we go. Whoops. We don't, let me do that again. Plus minus 0.99 plus minus 0.02 E8. Okay, that's what we got there. That should do it. That's right. There we go. And then this one is 431 plus minus. You know, you can underline that and make it a slick looking plus or minus. I just can't get to that function. This is like in this is a Mac version or something. Anyway, it was a student's data. There we go. Plus or minus 5. There you go. So now you all can do that same analysis for water over here. So do it right. I don't know what was done over here. That's not right. So all this stuff is not right. They fixed it. The student fixed their data. But anyway, there you go. You can do the same analysis that I just did here for glass, for your glass and your water. I hope that helps. Have a nice evening.